Chapter 3 is about the angles formed by parallel lines. We're going to look at some different angle pairs than the ones that you've had before, and we're also going to look at lines being parallel and define those words. So the definition of parallel lines, and this is in your packet for notes 3.1, are lines that have the same slope and never intersect. When we're making a diagram of parallel lines, we put these double arrows on our diagram, showing that we are marking that the lines are parallel to each other. We can't assume that lines are parallel, even if they look like they have the same slope, and these marks mean, yes, they are parallel. You can use that. The notation for parallel lines is kind of a vertical equal sign. So this notation would say L is parallel to M, and if I put a slash through it, that means not parallel. One way you can remember the word parallel is it has two vertical lines in the spelling of the word, two L's right next to each other, and those are parallel L's. In your packet, there's a problem for you to work through. Just try this one, making correct notation which of the lines shown in this diagram are parallel. So go ahead and do that. Okay, when I did it, I got that the parallel lines are M is parallel to N. And I can tell that they're parallel because they're marked with those parallel symbols. A transversal line is a line that intersects two other lines. So that's called a transversal. A lot of times, but not always, a transversal cuts across parallel lines. But a transversal is any line that intersects two other lines. Here's a picture. Line N is a transversal because it crosses both N and L, M and L. So that makes it a transversal. So if I want to use words to describe that, I would say N is a transversal across L and M. It has the word trans in it, like transcontinental railroad, which means goes across. When you have a transversal that cuts across two lines, it creates some angle pairs. I want you to get used to looking at a picture of a transversal across lines and seeing which angles are interior. The interior angles are the ones that lie between the two lines. So here's one interior angle. Here's another interior angle. So those are between the two lines that are cut by the transversal. Exterior angles are angles that are outside of the two lines cut by the transversal. So these are the exterior angles. Notice that those pairs of exterior and interior angles also make some vertical angle pairs. So we're going to be able to talk about congruence with these angles. But for now, know which angles are interior and which angles are exterior. So I'm going to give you a minute, so please pause the video so you can try marking up this diagram. This is in your notes packet. So the parallel lines are lines L and M because they're marked by that parallel notation. The transversal is N because it cuts across those two lines. The interior angles are 3, 4, 5, and 6 because those angles are in between the two lines. And the exterior angles are 1, 2, 7, and 8 because those angles are outside of the lines. This next page is a whole bunch of definitions of different types of angles formed by a transversal. The first type is corresponding angles. Corresponding angles are angles that are in the same position of the intersection cluster. So in this diagram, the pink angles are in the upper left of each cluster cut by that transversal. In this diagram, the orange ones that are marked are on the lower right position of their clusters. Those are called corresponding angles. When the two lines that are cut by the transversal are parallel, then corresponding angles are congruent. They're the same size. Alternate interior angles are going to be the pair of interior angles that are on different sides of the transversal. This word alternate is going to mean that we're on different sides of the transversal, and we already talked about interior. So in this diagram, we see alternate interior angles because they jump the transversal line and they're on the inside of the two parallel lines. Here too, these ones jump the transversal line and they're on the inside of the parallel lines. When these lines are parallel, then the alternate interior angles are the same size. They're congruent. The other thing you can note is that when you're looking for alternate interior, you can kind of look for that big letter Z. That letter Z indicates that you have alternate interior angles. Alternate exterior angles, there's a diagram. The only difference with alternate exterior, they're still alternate, so they're going to be on opposite sides of the transversal, but they're going to be exterior angles. Alternate exterior angles are also congruent. So if you have parallel lines, then your alternate exterior angles are congruent. We can also have same side interior angles. Same side interior angles are going to be on the same side of the transversal, but inside of the lines. So that's the definition of same side interior. When the two lines are parallel, same side interior angles are supplementary. They're not congruent, but they add up to 180 degrees. Same thing with same side exterior angles. They're on the same side of the transversal, but they're outside of the parallel lines. These angles are also supplementary to each other. They add up to 180 degrees. They're not necessarily congruent. In fact, most cases they are not congruent, but they add up to 180 degrees. They are supplementary. Okay, so you're going to try example 3, and when you have finished it, you're going to unpause the video and check the answer. Okay, on my key, I listed all of the possible answers you could have given, but you should have said A is parallel to B, and you should have said that the transversal is C. A pair of corresponding angles, you could say any one of these pairs. You could say angle 1 is corresponding to angle 3 because they're both in the upper left of their angle cluster. You could say angle 6 is corresponding to angle 8. So the corresponding angles are the ones that are in the same position on their cluster. Pair of alternate interior angles. There are 2 different correct answers, so make sure you have one of those 2 pairs. 2 and 6 are on opposite sides of the transversal in their interior, and 7 and 3. Alternate exterior could be 1 and 5 or 4 and 8. And same side interior would be 2 and 3 or 7 and 6. And same side exterior would be 8 and 5 or 1 and 4. Okay, the next thing I want you to do is identify for each of these which transversal you're using when you look at that angle pair. So for example, if I look at angle 2 and angle 8, the transversal that those 2 angles share is P. And for the, and these angles are exterior to the lines, and they are on opposite sides of the transversal, so they are alternate exterior angles. Okay, I'm going to have you pause and try these ones, or you can go along with me if you want to. So number 5, I'm looking at 9 and 13. 9 and 13 are on the transversal Q, and they are corresponding because they're both in the upper right of their upper left of their angle cluster. 6 and 13 are on the transversal L, and they are inside the two lines P and Q, so they are same side interior angles. 2 and 12 are on the transversal N. They are on opposite sides of the transversal, and they are in between line P and Q. So 2 and 12 are opposite side. They're not on the same side. They're jumping the transversal. They're on their alternate interior angles. Okay. The last ones I'm going to leave for you to try. I will put up the answer key in a moment, so pause and try those first. And some of them are not new words. Some of them are repeats. Okay. Here is the answer key for this. Please take a look at it. Oh, never mind. That's the one that we just did. Here's the answer key. All right. Notice how with linear pair there is no transversal, because the linear pair are the ones that are just right next to each other on a straight line. That's not a new angle pair. And same for vertical angles. Those are not a new language. There is no transversal that we need to list for vertical angles. They are the ones that are opposite each other on the X. Okay, that's today's lesson. Thank you.